Hello, welcome to another video tutorial by Easy Academy. In this video, I'm going to be covering how to run the Kafka performance benchmark with only default values. Now, the entire series is going to be about running you through how to do this when you're optimizing for availability, for throughput, for latency, and for durability. But in this particular scenario, I'll just run a very simple test and we'll show you how to use the default values to do that both on the producer and the consumer side. So let's take a look at what we have. So I have the different scenarios that I'm going to be running in subsequent videos, covering the four that I just mentioned: latency, throughput, availability, and durability. We will vary in the subsequent videos the number of producers that are creating these events, as well as the number of consumers that are creating the events. We will also try to change the size of each message that is being generated using this tool. Typically, Kafka would sometimes buffer the messages until it reaches a particular size altogether before it transmits the messages to the broker. So we'll see how adjusting the size of each message or each event will impact this behavior, and how fast we are waiting and how fast it's being sent over. We'll also vary the message counts. We'll start with 10,000, then we increase it to higher numbers and see how that is affecting it. We'll also modify the number of partitions for each topic that we're using in the test. We'll do for 1, for 6 partitions, and for 12 partitions. This is important because on the producer side, you may not really notice differences that the number of topics, the number of partitions in the topic have on the transmission. But when you come to the retrieval side, the number of partitions do matter because you cannot have more consumers within the group than the partition count that you have for your particular topic. If you have more consumers than the number of partitions for that topic, the extra consumers within the group will have to be idle. So if you are trying to have up to maybe 10 consumers within the group, then you have to have at least 10 topics. Otherwise, if you have just 8 partitions in that topic and you have 10 consumers within the group, then the other 2 will be idle. So you can scale up number of consumers for your topic, for your consumer group, but that will not affect anything. So this is very important when we're thinking about how to optimize the number of consumers within the group. We have to think about the partition size as well. Now, this may not be a big deal if you're using something called Confluent Parallel Consumer, which can use different strategies to still scale up the consumers within the group by using a different strategy and technique. So I will put a link to that in the description and you will take a look at that. Another thing that I want to cover is the cluster types. In this particular scenario, I'm using Kafka brokers with Zookeeper in legacy mode. I will also run in the other examples without Zookeeper in craft mode. And then this is the specs for our brokers. We also have certain knobs we're going to adjust, like the send and receive buffer, the batch size, the linger time, and the acknowledgement strategy, whether we want just the primary leader of the partition to respond, or if we want others to respond, or if we want everybody to respond. So we'll take a look at that and see how is that affecting the rate at which the producer is able to send messages to the broker. So these are all the knobs we're going to be tweaking in this test, and we'll see how the test behaves as we go through that. So let me go back to the test. Now, one thing that I have here is that we have different value files for availability for the different scenarios, but for this particular one, I'm going to be using the default scenario only. And then I have steps here for how to set up Kafka with Zookeeper. If you take a look at my tutorial that I'm going to put a link in this video on how to run Kafka in a box, I already have steps on how to do this. The only difference between this particular video and that video is that one was done with Kafka 2.8, but this is done with the latest version of Kafka at this time, Kafka 3.1. So basically what we did here is we ran the helm command to install Zookeeper, and then we run the helm command to install the 3 brokers. So our 3 brokers are ready here. So if we do this, we can see that we have our 1 Zookeeper node, and we have the 3 broker nodes. They've been running for about an hour, and they are prepared and ready to go. So once that is done, the next thing I had to do was to make sure that I created the topics. So I would have to log into this particular pod, one of the broker pods. So after logging into that broker pod, I would navigate to the bin folder, and then once I'm in the bin folder, I can run one of these commands to create the topic. However, I already created the topic, so I can just take a look at how the topic is structured. So we can see here that this particular topic, performance 12p, has 12 partitions, and it has only 1 replica. So basically only the leader is active in this scenario. All of them are in sync, so we are prepared and ready to go. Now, the first thing we have to do here is to run the helm command, but let's take a look at what is inside this default YAML file for the values. The producer would only be 1 producer because the parallelism level for the job is only 1, and then when that loads, it is going to load the properties file for default. So that is what we're going to be using, and then for the consumer, we're going to be using the default properties. So this is accomplished by mounting what is called config maps in Kubernetes. So the config map will map this particular file into the file system of the pod, and then the producer similarly would also mount this particular segment of the config map into the file system of the pod, and that will be used in the job. So by specifying this, we are just going to be mounting this path upon the pod for the job that is doing the producer and the consumer, and it will use those settings to override and make it happen for us. All the tests are going to be running through this particular topic called performance 12p. The consumer group will be called Easy Academy, and we'll try to retrieve 1 million records, and the timer will be 6 seconds here. So that is everything, and the producer would also generate about 1 million records. The size of each message will be about 8 bytes, so let's put that there. And then the default throughput here, meaning that we're not trying to limit anything on the producer side, so we can go as fast as we want. That is how we are doing this particular scenario. So the scenario that I'm walking through, we just use the message size of 8 bytes, and then we'll proceed with that. So to do this, I head over to where I have my Helm charts, and I have the command for the producer. So it's going to be Helm install benchmarks, and then I specify the path to the Helm charts, and I will override the default values and set producer enabled to true, which is false here by default for both the producer and the consumer. But I just want the producer job to run. So to do that now, I have to head over to this folder where I have this example, and then let me expand it so that we can see what is happening. So I run the command. The release does not exist, but it is doing it now. So if we do a kubectl with the performance namespace get jobs, it shows us that the producer job ran for about 9 seconds and it is completed. So let me increase this again so that you can see my screen clearly. So we ran the producer job, and it says that it has completed in 9 seconds. So that was about 30 seconds ago. Okay, so that is done. Now, how do we take a look at the logs? So I have the command here to take a look at the logs. So we're gonna do a kubes control performance logs, and then we specify the name of the job. So here it shows us some metrics that tells us what happened when the producer was run. So this is how we're able to review these numbers. So some of the numbers here that we have is the total number of records that were generated, the average time it took, and what we're going to be doing is we're comparing these numbers. So like this one here, the producer was able to send 1 million records, and we have timestamps, the sizes, the average, the minimum, the maximum, and all those different numbers to compare. So this is basically how we're going to be retrieving the metrics on the producer side. So basically the objective of this video is just to show you how to run the job, and then in the next videos we're going to dive into what each of these numbers mean. So please pay attention to the release schedule so that when I publish that, you will be able to take a look at it as soon as it's available. In this video, we're not going to be really covering what these numbers mean because it's quite a lot, but the main objective of this is to show you how to run this test. So we have the strategy for how to run the test on the producer side. Now let's take a look at how to do so on the consumer side. So remember, the consumer is going to attempt to pick up 1 million records. So let's go ahead and run this for the consumer. So when we do this, it's going to enable the consumer job and it's going to run it. Okay, so now the job is complete. Then let's take a look at the logs to see what happened. So if we do performance get jobs, we're going to see that the consumer job completed within 9 seconds. And let's take a look at the logs. So similarly, it was able to consume 1 million messages from 12 partitions, and we have similar metrics as well, similar to what we had with the producers. So here we can see the number of messages per request and how many messages were retrieved altogether from all these different partitions. So we consumed 1 million messages total, and we have all these different numbers. So this one here shows us the date, and then it shows us megabytes per second, data consumed, number of messages per second, and all those different metrics. So this is going to be very important because in the subsequent videos, as I'm running with varying number of consumers within the consumer group, as I'm running it with varying number of partitions, we're going to pay attention very closely to all these different metrics and how adjusting the different knobs are going to impact the numbers that we're seeing. The general trend here is that as you increase the number of consumers within the group, the number of time it takes to download all the messages should obviously be less as you increase the number of consumers. But we're going to see specifically how adjusting the response acknowledgement type is affecting things, how the buffer size is affecting things, how the linger time is affecting all the different metrics. This is very, very exciting, and I'm looking forward to sharing that with you in upcoming videos. So that is the end of this particular video. If you are new to my channel, please go ahead and subscribe to the channel, and you can also support the channel by becoming a patron at Patreon, and follow me on Twitter at Easy Academy for new content that I have, and you can also check out my website for current and upcoming content. Now, if you are looking to find out how to use open source software to aggregate, to store, to process, and to analyze data in real time and batch mode, you can take a look at my course on Udemy, and the coupon code and the promo code is available, so you can leverage that to get a discount when you sign up for the course. I thank you very much for your time, and I'll see you in the next videos.